Bismillahirrahmanirrahim. In this session, we will discuss exercise 13.3 from additional mathematics course. In this exercise, we will discuss vector geometries, and this is very important topic. And here we have in this example, in this problem, OA. This OA is basically a vector. This O to A is a vector which is defined as small a, and OB, this OB is a vector which is represented by small b, and R is the midpoint of OA. This R is the midpoint of OA, and this B is given as OP is equal to 3 times OB. This OB is multiplied by 3 to get this OP, and AQ, this A and Q is equal to lambda AB, is lambda times AB, and this RQ is equal to mu times RP. So this information is given, and find OQ in terms of lambda A and B. So we have to find OQ, O and Q, this vector have to find in terms of lambda A and B. Similarly, we have to find OQ in terms of mu A and B. The same vector OQ in terms of mu A and B, and find the value of mu and lambda and the value of mu. So we have to find the value of mu and value of lambda and mu. So let's solve this question number 1. Here we have question number 1. We have given all this information according to this figure. So OQ, this OQ from here to here, this OQ is equal to OA, O to A, and A to Q, or A to Q. So this OA is simple, and this A to Q, which is lambda AB. This information is given. AQ is lambda AB. So in place of AQ we can write lambda AB, and in place of this AB we can write OB minus OA. So this is OB minus OA. In place of this AB we can write this minus lambda OA first, and then lambda OB in second. So this rearrangement is written down like this. So this is one OA can be taken common here. So 1 minus lambda is there, and lambda is here. So 1 minus lambda, OA is small a, and OB is small b. So this is the first representation in terms of lambda A and B. So this OQ has been obtained as this. Secondly, the B part, OQ has been obtained in terms of mu and AB. So OR, here we have this OR and OR, and this RQ, OR and then RQ. RQ can be written as mu times RP, which is here in the information given in RQ. RP is equal to mu times RP. So mu times RP will be there, mu times RP. So OR and mu times OP. RP is given as OP minus OR. So this OR is mu times OR is here, and mu times OP is here. So this OR is taken common here, 1 minus mu, and OR is written here, and this is OP is 3 times OB. This OP is 3 times OB given here in this picture, or here also. This OP is 3 times OB. So this OP is written as 3 times OB. So this becomes 3 mu OB. So this mu, and this OB is basically small b, and this OR. So OR is half OA. This OR is half OA. Midpoint of OA, so OR is half OA. This OA is half OA, so half value here. So this in place of this half, so half 1 minus mu, and this is A, and this is 3 mu B. So A, B and mu. So the second part has also solved. Now we have to solve lambda and mu. So from equation 1 and 2 we can compare this 1 minus lambda A, lambda B is equation number 1, which is equivalent to OQ, and the same equation here which is also equivalent to OQ. This is also EQ, so the both are equal. So on comparison we can say that this A vector's coefficient is equals to this 1 minus lambda coefficient, and this B vector coefficient is equivalent to this this B vector coefficient. So this relation we compare, and these two equations formed, and from by simultaneously solving these two equations we have obtained mu is equal to 1 over 5 and lambda is equal to 3 over 5. This is the solution, and this is very important problem. Let's solve this question number 4. Here we have OA is equal to small a. This OA is small a, and OB is small b. This is small b. It's from here to here, and B is the midpoint of OD. B is the midpoint of OD. This from O to D. This B is capital B is the midpoint here, and AC is equal to 2/3 of OA. AC is 2/3 of OA. Is this AC is 2/3 of this OA, 2/3 of this OA. So this is also given here. AX is given as lambda AD, and BX, this BX is given as mu times BC. So this information is given. Find OX in terms of lambda A and B. OX, this O to X, in terms of mu A and B, and similarly find the lambda and mu. So this is question number 4. So let's solve this question 4. So we have given OA is equal to A, OB is equal to B, B is the midpoint of OD, AC is equal to 2/3 OA, AX is equal to lambda AD, BX is equal to mu BC. So we have to find the OX. So this OX is equal to OA and AX. So we'll write this OA AX, and in place of AX we can write lambda AD, and lambda AD is this AD is obtained as this lambda AD is basically AO and OD. AO and OD. This AD is basically A to O and O to D. So this AO is basically minus OA. So this is minus OA. So this becomes minus. So this is minus lambda OA, and this OD. So this OD. So we'll write this lambda OD. So in this case we can take OA common here. So 1 minus lambda OA plus lambda OD, and we know that lambda OD is 2 times of this OB. So in place of OD we can write 2 times OB. So this is 2 times OB. 1 minus lambda A plus lambda 2 OB. So this 2 can be multiplied by this. So this becomes a small b, and this is small a. So 1 minus lambda A plus 2 lambda b. This is the part 1. In the second part, OX has to form in this relation. So OX is equal to OB plus BX. This OB and this BX. This OX is equal to OB and then BX. So we have like the BX, and BX is given as mu times BC. So in mu times BC, and this BC can be written as BO plus OC. So B to O and O to C. This BO becomes minus BO OB. So this minus OB. So this OC minus OBC OB. So this is mu minus OB. This is minus mu OB. This is plus OC. This is 1 minus OB mu OC, and OC can be written down as OA plus AC, and this is OA. OC is basically OA plus AC. OA and AC. So in place of OA, this is there, and AC is given as 2 upon 3 OA. So this is this. So this becomes 5 upon 3 mu. This becomes 5 upon 3 mu. OA. This is mu. So this is OB. OB is given as B, small b, and this is A. So 5 upon 3 mu A can be written down first, and 1 minus mu, and this is small b is here. So this is the second part, which has represented OX in terms of mu A and B. And the second part, now we can compare this A and B coefficient from these two equations, equation 1 and 2. And on comparing, we have obtained two equations, and this from this two equations, this and this, by comparing the coefficient of A and comparing the coefficient of B vector, and from this we have obtained this lambda and mu as these values. So this is 3 upon 7, and this is 2 upon 7. Lambda is 2 upon 7 and mu is equal to 3 upon 7. So this is the answer. So by solving these two equations simultaneously. So this is also very, very important. Let's go back to question number. Let's solve this question 7. So here we have this OA is given as small a, and this OB is given as small b. O is the origin, and OX is lambda times OA, and OY is mu times OB. This is information is given. We have to find the BX. This BX in terms of lambda AB, and find AY. This A and Y. We have to find BX and AY. So the second part in terms of mu AB. So this is the first part, and the second part we have this 5 BP. 5 times BP is equal to 2 times BX, and AY, this AY is equal to 4 times PY. Find OP in terms of lambda AB, and find OP in terms of mu AB, and then find the value of lambda and mu. So we will solve this question number 7. Here we have this OA is small a, OB is small b, OX is basically lambda times OA, OY is mu times OB, and BX in terms of this, and AY in terms of mu AB. So BX is equal to this, BX is equal to BO. BX is basically BO and OX. So BO is basically OB, can be written down as minus B to O, and O to X is basically BX. So BO is basically minus OB and OX. So this OX minus OB, OX is this OX is basically lambda times OA is given. So in place of this OX we can write down this. So this is lambda A minus B. So this is the first part. In the second part we have to find the AY. AY is equal to Y0, YO. AY is AY. We have to find this AY. So we have AO and OY. So this is AO, YO. So this is AO and OY. So this OY minus OA, this can be interchanged. So this becomes minus sign. So this OY is basically mu times OB, and this is minus OA, this is minus A, this is mu times B, and this is the second part has been obtained. Now we have to find this B part. 5 BP is 2BX, and AY is equal to 4 PY, and we have to find the OP in terms of this. So OP is equal to OX plus XP. OP is equal to OX and XP. So and BP is equal to BP, PX is equal to BX. So BP and this is XP minus XP is equal to this is BX. So XP is equal to this XP is equal to this XP can be shifted here and the BX can be written down here. So this is BP is basically 2 upon 5 BX and this is BX. So this is basically minus 3 upon 5 BX. So here in place of this XP we can write this 3 upon 5 BX, and this is lambda A, and this is minus 3 upon 5, and this BX has already obtained in earlier session. Here this BX has been obtained, so this can be placed in there. So this was very good problem. So this OP has obtained in terms of lambda A and B. So on simplification we can find this value. So this becomes a part 1. In the latter part we have to find this mu in this terms. So we have this OP is equal to OY, YP, OY, PY. This YP is basically PY, and PY is given as this 1 over AY. OY is here, this AY is AOY, and AOOY is obtained as OY is here 1 over 5, and this is AO, and this is something like this. So minus 1 over 4, and this is basically 3 upon 4 OY plus 1 over 4 OA. This is OA. So this OY and this minus 4 OY is basically 3 over 4 OY, and the remaining 1 over 4 OA is here, and this is 3 upon 4 OY, and 1 over 4 OA is basically this negative sign can be changed with OA, AO to OA. This becomes negative plus. So this is mu AB. This OY is basically mu times OB. This is 1 over time OA. So this is 3 upon 4 mu B plus 1 over 4A. So 1 over 4A plus 3 upon 4 mu B. So this is the second equation. So this second equation, this first equation, and from this we compare the coefficients from here to here and from here to here. So this can be solved easily. So from this, so lambda is obtained 5 upon 8 and mu is equal to 4 upon 5. So this is very important question. In the next we have to solve another question, that is question number, let's solve question number challenging one, question number 9. So here we have this OA is equal to a small a and OB is equal to B. OA and OE is in the ratio of 1 to 3. So OA and OE is in the ratio of 1 to 3, and AB and BC in the ratio of 1 to 2, and OB and BD are equals. So find in terms of A and or B. So OE, the value of this OE in terms of A and B, and OD, this OD in terms of A and or B, OC, O and C, this one in terms of this. Find in terms of A and B, CE, CD and DE. Use this part B to explain why C, D and E are collinear. C, D and E. So this becomes a single line. So collinear we have to find the ratio of C, D and DE. This is very important, a very challenging one. So let's go to this question number 9. Here we have OA is equal to A, OB is equal to B, OAE ratio is 1:3, ABBC is ratio 1:2, OBBD same equals, OE is equal to have to find A and B in terms of this. OE is equal to OA, OE, OA and AE, and AE is given in terms of this 3 OA. So this becomes 4 OAs. So OE is equal to 4 OA. So in the second part, OD is equal to OD, equal to OB and BD, and BD is basically OB, so this is OB, so this is B plus B, this is 2 times OD is basically 2B. So OC, so we have to find the OC. OC is equal to OB plus BC. So this OB and then BC. So in place of BC we can write this 2AB. So this OB and this 2AB is basically 2. AB is basically OB minus OA, and this is 2OB. So this OB plus 2AB, 3OB, and this is 2OA. So this is OB. So this is 3B. This is 2A. So minus 2A plus 3B is the OC. Similarly, this AB and BC ratio is given. This information has been utilized here. In the B part, CE, we have to find the CE. CE is equal to AA plus AE. In place of this C, A is basically CB and BA, and this AE is here. So CB is basically BC minus BC, and this is BA is basically minus AB. This is this. So AB, so this is BC is basically twice AB. Information is given, so utilize here. So this becomes minus 2A minus AB minus 2AB, so minus 3AB, and this A is basically 3 times OA. Utilize this information. So this AB is basically OB minus OA, so 3 times this. So this is minus 3OB, this is minus plus 3OA, this is 3OA. So this is 6OA minus 3OB, so 6A minus 3B. Similarly for CD is equal to CB plus BD. So CB is basically B minus BC, and this BD is basically OB equivalent. This information is given, utilized here, and this BC is basically minus 2AB. OB is here, and from OB, AB, this can be OB minus OA, this twice is here, and then on simplification we have this 2A minus OB and 2A minus B is this information used here. DE is equal to DB plus BA plus AE. So DE can be written down here. So this is minus BD, this is OA minus AB, this is 3OA, so this is minus OB, and this is utilized here. So on simplification, this 4A minus 2B is there. So from part B, so CE is equal to CD plus DE, so 2A minus B, and this DE is 4A minus 2B, and by addition we have this 6A minus 3B. That's the point. C and D are equilinear because this C is given obtained as 6A minus 3B, while this C and this are added to get the same value. So they are collinear, so they are adding together to give this value. And CD and DE's ratios are obtained as this CD and DE. This CD is written here and DE is given here, and by comparing, and we have obtained this 1/2. So CD and DE are in the ratio of 1:2, which is very important question. In the next session we will discuss exercise 13.4.